All right, 490. Alyssa, you know what's going on?
Kind of.
Kind of? All right, what do you think?
4, negative 270.
Okay, good. Now, to me, that's the easiest one, is the negative angle. And actually, if you look at the A, B, and C up here, that would actually be the C part. But I always find that one first. Okay, I don't care what order you find them in. All right, what about after that?
Negative 4 and then 270.
Negative 4, 270. Okay, so think where 4, 270 is. That would be 1, 2, 3, 4 here. And since it's negative 4, it flips through the origin. Yep, that would be correct. And then what else?
That is the last one.
Okay, what would be the negative angle to go to 270? 270 is the positive here. What would be that negative angle?
Negative 90.
Negative 90. So negative 4, negative 90. All right, those are the 4 cases. Any point can be labeled 4 ways. All right, now you can also think about these as like on your regular coordinate system. We can label them with normal coordinates, like point Q. That point right there would be equivalent to 0, 4. Does that make sense? Here is 0, you go up 4. Now, the other points aren't as easy necessarily, but we're going to be able to convert between one and the other. All right. All right, read through that on your, I think that's on there. Read through that, take a look at that picture. Carter, let me see that one more. Because I know I got to figure out how. I think it fucking. Yeah. All right, yeah. All right, well, I need to fix it, we gotta figure that out. Hey, this all boils down to right triangle trig. Okay, converting between polar to rectangular and rectangular to polar. And then once you see it, hopefully it'll make sense. Like that point right there, I could label with an X and a Y, or I could label it with an R and a theta. I can get to the same point 2 different ways. Now, once you drop that perpendicular down, you're gonna see I got a right angle, okay? Now, here's going to be your relationships. That's that next picture down. So x squared plus y squared equals r squared. I think we agree with that. Sine of theta equals y over r. That means that y equals r times sine of theta. Okay, because if you think it now, that doesn't have to be the reference angle. We can use the actual angle because that'll give us the sines we need. And that also means that x equals r times cosine of theta. Okay. Tangent of the angle is equal to y over x. So all our right triangle trig applies. Now look right to the right, and it tells you the rules, and it should make sense because we just kind of talked about it. How do you convert from polar to rectangular? Okay, converting from polar to rectangular, x equals r cosine theta, and y equals r sine theta. So if we know theta, we know r, multiply those together, and then we get our rectangular coordinates. Okay, let's take a look at an example. This is down there at the bottom. You should have an A and a B. A is 350 degrees. Since both of these are unit circle angles, I'm going to want the exact answer. Don't give me a decimal that your calculator spits out. So you're going to have to think about your cosine and sine. All right, 3 150. Not that you have to draw it, but I'm going to do it because it's fairly new. And 350 degrees, you go out 3 radiuses, and then 150 degrees would be over here. So it'd be around there, which is quadrant 2. So think about your coordinates of your x and your y. X has to be negative, y has to be positive. All right, so x equals r times cosine of theta. Y equals r times sine of theta. X equals, what was my r? 3? Cosine of 150. Y equals 3 times sine of 150. All right, take a second. Think about what the cosine of 150 is. Think about what the sine of 150 is. Their exact values. Don't round them off. And I'm just going to draw it real quick over here because just remember for 150, that gives me a reference angle 30. That means across from it's 1/2. And make sure you label that negative square root of 3 over 2 because it's cosine of in quadrant 2 is negative. So I get 3 times negative square root of 3 over 2, and y equals 3 times 1/2. And in the end, my ordered pair, I can't do much with it. Negative 3 square root of 3 over 2, and then 3/2. Okay, like that. So that is equivalent to which point? It is equivalent to 350 degrees. So they're not going to be nice all the time, in terms of like 2, 4. All right, take a look at the second one. If you think you're good, go ahead and get started. I'll do it here in a second. I'm going to draw it out first. Where is negative 4 pi over 3? Think about where it's at. Use negative 4 as your R value. Do not make it a positive. You use it whatever it tells you. Use negative 4. Oh, that's a little lopsided. All right, negative 4 pi over 3. I'm going to think where 4 pi over 3 is. Pi over 3 is 60 degrees. We're going to go through the origin to the back side. And so negative 4 pi over 3 is actually going to be in quadrant 3. So that needs to make sense where that point is. All right, now x equals r cosine theta. And y equals r sine theta. Use negative 4 for your r, so it's negative 4 times cosine of pi over 3, and y equals negative 4 times sine of pi over 3. All right, take a second, think about what pi over 3 is. You know that, keep going. Or cosine of pi over 3 and sine of pi over 3. Okay, and cosine of pi over 3, that's cosine of 60 degrees, which is going to be positive 1/2. So negative 4 times positive 1/2 will give me negative 2. Okay, I'm going to simplify it, and then y equals negative 4 times square root of 3 over 2, which simplifies to negative 2 square root of 3. So my point is negative 2 square root of 3. Needs to make sense that both of them are negative because, it's, like we said, that point is in quadrant 3, so that has to match up. All right, that's how you go from polar to rectangular. On the back, there's rectangular to polar. Pretty similar. I'm going to change, I don't want to say change, but I'm going to modify something slightly, okay, slightly on here. To find r, you're going to use Pythagorean theorem. Now it says find theta by using tangent of theta equals y over x. I want to make sure you know that gives you the reference angle. And I'm just going to say that theta prime, which is my reference angle, equals tangent. And I'm always going to do the absolute value and then either add or subtract it from 180 or take it away from 360. But you got to recognize what quadrant you're in. And so this is going to be my reference angle. Okay, for that. If you use a negative, the only thing it will do is give you back maybe a negative angle. You just got to recognize that, you don't need the negative. You can drop it and just add or subtract it, like I said, from 180 or 360. All right, let's take a look at that example they got there. I think yours says 2 pi. I'm going to go ahead and do 360. You can change that in your guided notes to 360 there at the end. We'll just do it in degrees. All right, I want the polar coordinates of that point. Now, -2, 2 radical 3. Two radical 3. I'm just getting this for an estimate. 2 square root of 3, about 3.5. So -2, 3.5 is right there. So I want to find the polar coordinate, the r value, and then the angle. Well, how do I find the r value? It is r equals the square root of x squared plus y squared. All right, try that without punching anything in your calculator. See if you can do it without calculator. It comes up to a nice number. Good practice here with your radicals. And so you get r equals the square root of -2 squared plus 2 radical 3 squared over. All right, I'll give you -2 squared is 4. 2 square root of 3 squared. Jaden, what's that going to be?
That's going to end up being 12.
12, because you're taking 2 square root of 3 times 2 square root of 3. 2 times 2 is 4. Radical 3 times radical 3 is 3. You get 4 times 3, which is 12. 4 plus 12 is 16. Square root of 16 is 4. So it ends up being a nice number. Okay. Now we want the reference angle. Well, not that you have to draw it, but we know it's in quadrant 2. This is my reference angle. I know this is -2 and this is 2 square root of 3. So my reference angle, theta prime, is inverse tangent. Absolute value, I'm just going to drop any negatives. Okay, I'm just going to take care of it now. You can type that in your calculator, but what cancels, just to make it a little bit easier? The 2's cancel. So we can cancel those, and I get theta prime equals inverse tangent of square root of 3. All right, go ahead and use your calculator if you want to. You don't have to. Emily, let me know what you get. 60 degrees. So we get 60 degrees. That's our reference angle, though. So the actual angle in this case will be 120 minus 60, which is 60 in my ordered pair. Okay, ordered pair will be 420 degrees. Oh, why did I say 120 minus 60? Sorry. It's going to be 180 minus 60, which is 120 degrees. And I don't know if I can draw this accurate or not. Probably won't. Oh, that's a bad one. But if you take a look, 3, and then 4. And so it's right there on that 4, and it's going to be at 120 degrees. So that's how you go from polar to rectangular, rectangular to polar. All right, I'm going to wait till tomorrow to do the graphs, okay, because they're not too bad, but I don't want to rush it. And there are a few problems here. On these, it gives you a point, I don't know, like 240 degrees, and it says to graph it, but then it says to list the other 3 points. You know how we did that? You just need to list the other points. Okay, if you want to graph it, I'm never going to tell you no. But you don't if they have to. let's see here, let me stop this.